In this video, I'm going to talk about the assumptions of classical linear regression model that you encounter while studying simple linear regression. One of the mistakes that students do while studying simple linear regression is that they do not pay enough attention to these assumptions. See, you have to understand this part that these assumptions that you see in simple linear regression, these are quite important, and you will see these assumptions again and again. For example, whatever assumptions you are going to read in simple linear regression, you will have an extension of these assumptions in multiple linear regression. At a later stage, you will also see that there will be some chapters where we will violate these assumptions one by one, and then we will see how the framework is going to change. Okay, so if you do not have a good understanding of the assumptions, while you are doing simple linear regression, you're going to struggle in connecting the dots. So whenever you are reading these assumptions, make sure that you spend a good amount of time on understanding these. The beauty of simple linear regression is that you are only working with two variables, and when you work with two variables, you can also make scatter plots and actually try to visualize these assumptions, which will also help you with the understanding. So now I also want to talk about the Gauss-Markov theorem. So Gauss-Markov theorem. See, the estimators that we have are beta 1 hat and beta 2 hat, and because we find the estimators using the method of OLS, we can also call it OLS estimators. Now, as per the Gauss-Markov theorem, the OLS estimators, that is this beta 1 hat and beta 2 hat, they are blue, so BLUE, given that this is important, the assumptions are satisfied. So given that the assumptions are satisfied. Okay, now see, you need to note a couple of things over here. First of all, what is the full form of blue? So blue means B stands for best, L stands for linear, U stands for unbiased, and E stands for estimators. So blue means best linear unbiased estimators, and the Gauss-Markov theorem says that the OLS estimators are blue given that the assumptions are satisfied. Note that the OLS estimators are not always blue. If you want the OLS estimators to be blue, you have to make sure that the assumptions are satisfied. And the assumptions that I'm talking about are the assumption of homoscedasticity, are the assumptions of random sampling, and so on. So when you're reading the assumption, you need to understand this linkage really well. So what I mean by that is that there is an assumption of homoscedasticity. Okay, now I'm not going to explain you over here that what does this assumption says, but there is an assumption of homoscedasticity. Now you should be able to understand that what is this assumption linked to. For example, even if this assumption gets violated, okay, nothing happens to this unbiasedness property. So you need to understand all the linkages properly. For example, for linearity, you do not need all the assumptions. For unbiasedness, you do not need all the assumptions. Okay, so even if the homoscedasticity is violated, okay, that means, let's say if you have heteroscedasticity, okay, so heteroscedasticity is the term that we have when the homoscedasticity gets violated. You should have this level of understanding that in the case of heteroscedasticity, the unbiasedness property is not sacrificed. So this property is still over there. Okay, so you need to understand the linkages really well. The last thing that I want to talk about in this video, that you will also see one assumption that UI, which is the population error term, it follows normal distribution. So UI follows normal distribution. So there is also an assumption which is related to the distribution of the population error. Now, one thing that I want you to note over here is that this assumption about the distribution of the UI has nothing to do with the blue property. Okay, so this is an assumption on the error, but this is an assumption on the distribution of the error. So this particular assumption has nothing to do with this. Okay, so it doesn't matter whether UI follows a normal distribution or not. If the other assumptions are satisfied, then the OLS estimators are going to be blue. Now the question is that if this assumption is not required for OLS estimators to be blue, then why are we going to introduce this assumption? Well, the reason we introduce this assumption is because this assumption helps us in hypothesis testing. Okay, now I'm not going to explain you over here that how does it help, but I'll just give you a hint that if you take this assumption about the distribution of the population errors, then you are able to say something about the distribution of the estimators, beta 1 hat and beta 2 hat. So using this assumption, you can say something about the distribution of beta 1 hat and beta 2 hat. And once you get to know the distribution of beta 1 hat and beta 2 hat, it helps you in the hypothesis testing. So once again, when you're reading simple linear regression, make sure that you're paying good amount of attention to the assumptions. You're trying to visualize the assumptions, and you should understand all the linkages that are involved.